Hey everybody, this is Larry. This is day 27 of the Leetcode Daily Challenge, I think. Yep. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's forum. I've been feeling a little bit unwell today, so this video is a little bit late. I hope this is okay. But yeah, okay, hmm. So today's problem is maximum XOR of two numbers in an array. This is a weird problem. Yeah, I hope everyone's doing all right though. It's really cold in New York still. Yeah, gotta do a little bit better about that. But yeah, maximum XOR of two numbers in an array is kind of a possibly tricky problem. My first inclination is to use a try. And the reason why we can use a try here is that you try and do basically greedy in a way, in that XOR, and this is a lot of exploration. So if you haven't seen these type of problems before, it may take you a long time, and that's okay, because for me, I've done all these explorations, so it looks fast. But I've definitely like thought about like, oh, is this the case? You know, you make these observations, and sometimes in a lot of my videos, I talk about observations, especially during the contest ones. But these observations, sometimes you make them quickly, sometimes you take a long time or longer time. Because for me anyway, it's quick because I've done it before and I'm able to prove to myself that's correct. But if I was to see this for the first time or first time in a while, I'll be like, okay, you know, and some of it manifests itself as intuition if you have enough practice as well, right? Like I might be like, oh, it may be greedy on this one thing, but I'm not quite sure. You know, so then like you're like, okay, and then you take out a pen and paper and then you write out a lot of stuff, and you're like, well, can I find a counter example? Is this true for this weird case? And you know, so at the very least you play around the problem. Maybe it's not a strict mathematical proof, especially if you're like me and you're not necessarily a good like math prover type thing. Or at least a rigorously good math prover. Like I feel like I have a good intuition, at least for the level that I needed for Leetcode and such. But so yeah, so then the idea is that just to play around with all these properties, and then eventually you get it. For this one, I'm gonna make a couple of observations that I've already made before. I don't know if I have a video on this, but I probably have something video similar. I'm actually also surprised that this is medium, unless I am. Yeah, I guess I had to double check for a second to see that n is big enough that you can do n square. Because if you do n square, obviously it works, but it may be too slow, right? So yeah, so the first intuition is a try. Yeah, the idea is, the idea is that, okay, XOR is a function. So I'm just thinking about whether there are different solutions that maybe I'm just like, because one thing that sometimes happens as well is that as you get more and more experience, and as you have accumulated a lot of different tools under your tool belt, you tend to sometimes like you have a smash hammer and like you smash everything even though it's not necessary. Right? Maybe there's a simple solution that I'm just like obviously missing, but I'm like, oh, I have this tool, let me use it. And this happens sometimes, as you can kind of see in some problems where there is a simple solution, but people are like, oh, you could just use segment tree or something like that, where you're like, what? This is so not necessary. And also for me, to be honest, I don't use segment trees that well. But so yeah, so I just want to make sure that, or maybe I wouldn't say make sure, but take an extra second to pause to make sure that maybe there isn't an easy way. But yeah, so the first thing you notice about XOR is that all the bits are independent, right? What I mean by that is if you draw it out, you know, I'm just banging on the keyboard for random ones and zeros. If you draw it out, you know, and XOR is a function that allows you to yeah, XOR is a function that allows you to, like, everything is bit by bit, right? And when I say independent, what I mean by that is that what happens in the first bit doesn't change what happens in the last bit. And then part of that realization of that independence, and it comes up here and there randomly, part of that realization means that you can be greedy, right? If you're looking for maximum or minimum in this case, I don't think it matters, or like, you know, it's like the opposite of it, but the idea is the same exactly. Yeah. And then the idea here is that, okay, because all the bits are independent, then the question becomes, okay, can I make the first, like, let's say, we have some, random number that we don't know, right? Or maybe, obviously the digits are different. So, or, well, I guess they're not all distinct, but, they're just maybe some numbers, right? So then here we go, okay, in a greedy way, let's say we're given this as an input, right? Maybe I'll use a smaller number just to be easier. Let's say we have 25, right? 25 is what? 1 plus 24, which is, maybe I should have chose the easier number. 16 plus 8, right? 16, 8, 4, 2, 1, right? So then now you have, I can't do alphabet clearly. But yeah, so you have this 5 numbers, right? And then the question is, okay, in a greedy way, and of course, technically, you should have padding because there are 32 bits. So you would maybe actually have something like this. Let me do this, right? So then the question is, okay, the first thing that I would try to do is there a number that allows me to make the first digit a 1, right? In a very greedy way, literally. Because if there is, it doesn't even matter what the rest of the one, I mean, you will also greedy on the rest of it, but suppose that there is an answer that allows you to do and also do, right? In that case, no matter what you do in the rest of the digits, this number is going to beat it, right? Because in a most significant digit, it has a 1 where the other one has a 0, and that's the exploration that allows you to get. That's the exploration that allows you to use greedy, is because this precise thing where you really only care about 1 digit at a time. And of course, once you kind of fit this, okay, let's say you can make a 1, then you just ask yourself, can I make the second digit a 1? Maybe not, then 0. And then can I make a third digit? And then so forth, ... And that's basically the algorithm. And of course, once you kind of realize this, and once you have enough practice or so, you realize that you can implement this with a try, because you're basically searching existing numbers, one number. I mean, and you don't, I guess, at least to do it in a very constant time, you could do it one at a time of, is this a one, if this is a 1, then we need this to be a 1, right? So then we ask, is there any number where the first number is a prefix of 1? If this is, well, in this case, we try to find the 1 first, but let's say we can't find it, and so forth, right? So, going all the way down to say the D, we go, okay, well, we still want a 1, so there exists a D that is 0, right, on that try. So that's basically the story. And that's basically the idea about implementing this. Hope this explanation makes sense. I think that yeah. I mean, I think that's pretty much all the ideas I have for this one, and then it just comes to implementation. Yeah. Yeah. Okay. Sorry, got pinged for something very quickly. Not important apparently, but okay. So then now let's implement this try. 2 times 10 to the 5th is a lot. We'll see if this is going to be fast enough, because the way that I always do it is using a try data structure. And that's the way that I always recommend, especially if you're studying for an interview. That's the way that like ideally you would implement it. And of course, if you implement it correctly, on an interview, you're not going to get, like, there's no time limit exceeded. They're just like, no, this is linear, this is roughly optimal, maybe there's some sugar, but that's fine, right? Yeah. And this is roughly speaking, I mean, I'm not really explaining this part, because this is roughly speaking how I whatchamacallit, how I implement this every time. To be honest, I usually do write this as a dictionary, because it will apply more than with zeros and ones. But I think someone told me, or I don't know, I think I would vaguely have some idea that, and this is more Leetcode specific, to be honest. I have some idea that this may be too slow. So I worry a little bit whether this is too slow. So yeah. So we'll see. I could add helper functions. So. And I don't know if I'm in love with this one, but if self.0 is none, so this is probably a little bit of a premature optimization, honestly, but that's okay. You know, I feel like this is also, I wouldn't say it's not clean code for production, but it's clean. I think it's clean code for understanding. So I feel like that's okay. Because I think for production this looks a little bit awkward for sure, because you know I'm repeating myself a little bit, as you can see, but that's fine. But I do want to visualize the try for you a little bit better. Yeah. And then I usually also have like is n type thing, but we know that this is going to all have the same length, which is 32 bits. So that's why I don't need this for this one. So yeah. And then now we go maybe an add for a number and then a search, right? That's our API. I guess we can, I don't know how, I mean, I think for an API, we should have them in two different functions, but maybe a premature optimization is add and find max, something like that. Maybe that's a little bit awkward. We'll see if that works. Because I do want to put it in the same time, maybe. But yeah, okay. So then now we just have to write this out. And of course, if you're doing it at home and in theory, you would yeah, in theory you would write unit testing and stuff like this, so that it becomes a lot, you know, you get more confidence about the correctness and stuff like that. But you know, I'm just playing around, so it's fine, I think. Okay, so yeah. I guess we go down different paths, so maybe it doesn't make sense. So maybe I'll do a add and find max, because I think you want to go actually literally the opposite thing. So opposite root of the tree. I didn't really think it through. So yeah, so for I in range of from 31, yeah, 31 minus all the way to 0. Whoops. Go. So this is the bit shift operator. You could use power math as well. Like you start with the power of 2 to the 31st and then divide it by 2 afterwards. That's actually probably better, because then I don't have to shift it a lot of times. So maybe that's slightly better. So okay, let's start with that. So P is equal to let's just say power of 2 to the 31. And then I guess in this case I don't need this awkward loop. Yeah, I guess this is better. I always because I think this is because the 32nd bit is the, well, this is an unsigned int, so I think that's why I'm a little bit from. Wait, is it? No, it's not, Larry. What are you? I'm getting really confused, but that's okay. Yeah. So at the end we want to divide it by 2. Oops, by 2, and then for now we go current is equal to current dot go. Well, go what? Well, if this is where I do. I know that I've been using not bitwise operations here, but I guess this is where I do actually need this. And basically what I'm doing here is saying, you know, so P is going to be a number that's has a 1 with a lot of zeros in it, because it's a power of 2 number, and then as we go through it's going to remove some zeros at the end, right? And what this does is that this takes the input number. Let's say it's, again, I'm banging on the keyboard a little bit. So then here it goes, okay, let's say we look, the n would compare, the n would compare the bit at here, and then after we divide it by 2, it looks at the next bit, and then the next, and then the next bit, and so forth, right? And then we just go to the 0 and 1. Actually, and I did this wrong here, because I meant this as to get to add, but actually this is find max, so I actually put it in the wrong place. So that's my bad. Sorry for the confusion, because I didn't go over the logic. Okay, so this allows us to get to add things to the very end, because I will go add things anyway, right? So then here we go. I think I messed up a little bit in my API, because we want to check without creating. So actually, we still need a has 0. If it's 0, then it's not. So okay, so yeah. Right. So then here, now the same logic here, but the same for loop here, but different logic a little bit. Basically, we go, okay, going over that in a second. This is if number is if this bit is 1, then we want to find a 0. So then if self dot or current dot has 0, then good. Then current is equal to current dot goes 0, and it means that the So I'm just trying to see whether we trying to find the max. We have to return the number or the maximum result, but we can actually keep track of the path that we go to, and then just return the answer afterwards, right? So here we can have answer is equal to 0 to start with, and if this is 0, then yeah, we don't have to change anything to the answer, because that bit has a 0 in it, right? And then else, if there's no 0, then this bit is going to be a 1, so we have to go current. Actually, okay. I was trying to think about whether there is a case where it doesn't have 0 or 1, but I don't know if it's pigeon. I wouldn't say call it pigeonhole, but every as you can see here, the precondition, the invariant, is that after every core of this, every path, there's always a path that goes 32 nodes deep or 31 nodes deep, maybe off by 1. So there's always a route to the end of the tree. Otherwise, so there's no like dangling leaves except for at the very last, at the very last, one leaf, right? So there's no like leaf in the middle. So that's why I could go. I could do this without worrying about there's not a 1 here, right? And if there's a 1 here, if we're using the 1, then update answer, right? So then answer, now this is a bitwise thing, but actually I guess technically without bitwise you could also use this. So then now we know the answer because this is the power of 2 stuff. And of course, before I forget and have to debug, let me put this here at the end. Okay, so then now if else this is 0, if this bit is 0, then we want to find a 1, because if we have a 1, then if we have a 1, then we do it. And of course, in this case, we have to update the answer. Otherwise, then current is equal to current dot goes 0. And then at the very end, we have, so current now, not current, oops, answer now contains the number which would produce the max. So to get the max, all you have to do is just return answer XOR the number, and that's pretty much it. Yeah, and that's pretty much for the API. And now let's actually write the code, which would be very easy, because first we set let's say try is equal to try, and then for x in nums, try dot find max of x. Yeah, so let's say best is equal to 0 for whatever reason. Actually, what if it only has one number? Oh, I guess it could do itself. Huh. Okay, so it could do itself. So now we want to add itself first. That's the only difference. If you cannot do itself, then you would put the add afterwards. But in that case, I would see what the best answer is. But here you could just add 0, and then now you get an answer for this, and of course you just want to maximize this for matching it. So that's pretty much it. This is pretty straightforward at that point, I hope. And then let's run it real quick. The only concern I have about this is apparently off by 1. Do I need this to be 32? Maybe I need 32. And I just messed up. This part I am a little bit weaker at. Because maybe just missing the last digit. That's not true, is it? Did I start too big and I forget to keep track of the last number? Huh. It is funny that this is exactly off by 1. So it feels like I'm missing the last digit. But it at least shows that we have a good progress. But that's awkward. I'm not gonna lie. And I'm also not gonna, like, I do write this a little bit. The reason why I'm a little bit confusing but not as confident is because for teaching purposes, I'm not writing this the way that I would normally write this. So that's why I have to kind of double check a few things. Yeah. No, I mean, I think this should be independent. Let's see what is P at the end. Maybe I divide stuff a little bit late. Maybe I'm off shift by 1 here. I think maybe that's it actually. Because 1 should be 0 if I'm doing it right, and that means that the last number that we the last number that we check should be 1. But because it becomes 1 after the loop, then I think I just messed up somewhere. So this should be 31. I think I just confused like myself with all these bounds. Yeah, because usually I write this a little differently. I think that Python is just weird sometimes. Okay, so there you go. Just off by a slight easy off by 1. Okay. Yeah, the only thing that I worry now is maybe time limit exceeded, because Leetcode is sometimes very sketchy about the timing, and it seems like past times I'm very close, and I don't know. We'll see if they add new cases or anything like that. But at least an idea we're right. Don't give me a time limit exceeded, please. Oh, jeez. Let me look at what I did last time, because I don't feel like I didn't see. Yeah, I did the logic mostly the same. In fact, I did it with a hash table, and this is literally exactly the same. So so that's just really annoying, because it means that I have to do some like very constant. It probably means that they added more test cases, and that just makes the time limit exceeded. That's kind of I mean, I don't know why they needed more test cases, or at least like if they're going to do that, add more timing for Python. Because Leetcode does this thing where when it runs your code for time reasons, it actually runs it takes the total time of all the test cases. So in that sense, you have to almost, like, it's not good enough that it's fast enough for this number. It has to be fast enough for this number times the number of test cases. And obviously from here, it's unclear or unreliable that how many test cases that I'm given, and as a result, it's a little bit dubious in that. Yeah, as a result, it does make it very sketchy, but because I feel like, how did I do that 2 times ago? Yeah, this looks pretty much like I did the same thing every time, right? But yeah, so I don't know how much time I want to spend in doing this, in like just making some crappy optimization that you don't really learn anything from. But this should be right. So This is silly. I mean, I don't. Yeah, I don't know. Am I doing something really weird? I guess so. I mean, I have a lot of functions. I think that's maybe why. But this is very awkward. I'm just trying to see. Yeah, because like so this code is most certainly right. Um, it's just about doing this in a better way. And the reason why this, I think, it's just because yeah, I mean, I think it's because one reason why this is a little bit slower than and it could be is because of all these additional functions. Because the functions does add up, and if you do it like millions of times, of course, and if you do a million times the number of test cases, it'll be more. And usually, if you're using Python, these things don't, or like you kind of already taking it into account, it doesn't matter. But I guess for here, it's a little bit too yucky. So I'm gonna do some like things that I'm not happy about, but please treat my code kindly. This is not, I try my best a little bit. I mean, I wouldn't say my best, but I tried it anyway. So yeah. Okay. I guess I just have to do it manually. Du- 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 du. I'll see if this is fast enough. If this is not fast enough, I'll have to do more. But that's basically what I'm trying to do here. And I don't know if this is enough, but this is not fun though. But oh, did they give me a case actually? Oh, they didn't give me a case because it passes for all of them. It took too long. Okay. Thanks, friends. Okay, fine. Let's see. And you may wonder why I did this refactor first by removing this code, is so that when I run it as testing, if something is wrong, we would know, we would get an error, right? That's basically the motivation here. I mean, I don't always remember to do stuff like this, but I do want to point out when I do. Okay, see if this is a little bit better. I wish they at least give me a. Oh, whoops. I wish they at least give me a little bit of a, like it didn't even give me a test case, so I don't know if this is much faster. But let's give it again. This is annoying. This is silly. Hopefully this works though. If not, then I have to do more optimization, which is going to be sad. How can I even do it? Okay. How long is it? 8 seconds. This is just silly though. I don't know. I think they have to 667. 2/3 of the way to 1,000 days. But yeah, I think they just need to be a little bit better about it. I don't think there's anything like, I mean, I think I did a good job in terms of explanation. I do like the abstraction, obviously. And in fact, I would say this is like, if I was on an interview, this is the abstraction that I would want to have. Maybe a little bit less specific. Like I said, you could try the zeros and ones together and using a lookup table or something like that. But the idea is mostly there. Let me kind of show you all the code so that you can kind of see at home. Here's the first half. Here's the try. And here's the XOR. So let's go over the complexity. This is going to be O of n iterations, and of course, we'll look at the add function here. Here this operation is of course O of 32 or O of 1 or maybe O of alpha, where alpha is the number of bits. In this case, it goes up to 31 or 32, depending on how you say it, right? So yeah, because this is just a for loop that goes 32 deep, and these other functions are all of 1. So same thing here. Honestly, you do the same thing, and yeah. So because this is the O of n loop with this being O of O32, whoops, or O of 1, this is going to be a linear time algorithm. In terms of space, this is going to be O of n, because in the worst case, every number, I guess technically is the min of O of n, or the number, or 2 to the number of bits or something like that, right? Because at a certain point, due to pigeonhole, it will have to go through, but you get the idea. Okay, that's all I have with this one. Let me know what you think. Hope y'all have a great rest of the week. Stay good, stay healthy, take good mental health. I'll see you later. Bye-bye.